Alright, so here we are with identifying, evaluate, add, and subtract polynomials. So polynomials from Chapter 3, Section 1. We're also going to classify and graph them as well. So going ahead and getting started, we've got our standard form. So standard form of a polynomial is, as you can see, a bunch of what we call terms, okay? And so we want to make sure that every time we write them, they're kind of in this same order. Otherwise, you kind of have no way of comparing them. So, as you can see, maybe, the degrees are actually in descending order. So if we evaluate here, we've got a 3, then a 2, then this is not necessarily mentioned, but it is a 1, and then this would actually be a degree of 0. So we are going to go in descending order. Alright, we also have the fact that there are 4 terms. So we've got our first term, second term, third term, fourth term, and so that's going to be important. We also have something called a leading coefficient. Turns out each of these has a coefficient, alright, but if we look to the highest degree and the number out front, that is our leading coefficient. And then the degrees of the terms, again, go in descending order. So start with the highest, which is 3. If any of them are ever missing, you would just skip over that one and continue in a descending order. So taking a look at what we have here, the correct order is always highest to lowest degree. Ooh, height. Alright, and then a term is going to be each of these pieces separated by addition and subtraction. Alright, so again, a term is each of these pieces, and our correct order is from highest to lowest. So the next thing that we get to look at is how we classify or name a polynomial. And just like you, it turns out that you have a first and last name, and so do polynomials. So this is kind of their first name, and this is their second name. So your first name is going to go by the highest degree. So taking a look at your highest degree, if we go with the example we had before, our highest degree was 3. So the name for this would have been a cubic. Okay. We also have an example here, but again, as you can see, it has a 3 as its highest degree. And then you can kind of see here, there's a 1 as its highest degree, even though it's not written there. 5 is its highest degree. And so you are going to need to know these names. So if you have 0 as the highest degree, we call that a constant, and we will be using that word actually quite a bit. A linear, as we've seen before, of the mx plus b variety. Our m in this case would have been a 1, our x, and then our b would have been -4. Then we have quadratics, which we've been investigating a little bit in Chapter 2 when we were factoring them and all of that good stuff. We've also got a cubic, which again means that there's a power of 3, quartic, power of 4, and a quintic, so that's power of 5. After we have a first name, then we have our second name, or our last name. And so in order to get to the last name, you need to find out how many terms there are. So again, taking a look at our previous example, there was 4 terms. So if there are 4 terms, we call that a polynomial. Turns out that basically after 3, everything is a polynomial, because poly means many. So in this case, tri would mean 3, bi is 2, and mono is 1. And so in this case, we'd have a trinomial, and it was a cubic. So in our previous example, we had a cubic trinomial. So you're always identifying what is its degree, and then how many terms. taking a look at this example, or set of examples, we're going to rewrite each polynomial in standard form. So remember that means highest to lowest degree. So as we go through here, just identifying what the degree is. There's a degree 2, a degree 1, and a degree 0, because that's our constant. So we're going to rewrite this starting with degree 2, which does have a negative 5 out front. The second one is a degree 1, so we have a positive 4x. And then the last one is our constant, which is a 3. So taking a look at our leading coefficient, that's the number way out front. That's going to be negative 5. Our degree, again, is going to be the highest power, so that's 2. There are 3 terms, so 1, 2, 3, again separated by plus signs. And then our name is based on the degree, and the number of terms. So degree is 2, and so that's going to mean that we have a quadratic. And then the number of terms is 3, and so that's going to mean a trinomial. And so our official name is a quadratic trinomial.
I need you.
Alright, the next one here is a 4 for the power. We also have a 2 for a power, and then because it's a constant, a 0 for a power. So as we go through and rewrite this, we're going to start with an 8x to the 4th. The next one is a 3x squared, and then the last one is the 0 power, or the constant, which is 4. Our leading coefficient is the number way out front at the beginning, so it's going to be 8. Again, when we use that idea of the number way out front, there will be times when they put them in the wrong order, and you just skip to it being a 3. But again, it's the number way out front if it's in standard form. So 8 is our leading coefficient. The degree is going to be 4, that's the highest degree. And from the number 4 for our degree, we're going to end up calling it a quartic. From our number of terms, we have 1, 2, 3 terms. And so that's going to be a trinomial. And so our official name for this is going to be a quartic trinomial. Alright, taking a look at our next example, we're going to add and subtract. And hopefully we know that we can only add things that have the same power. So if we grab a few colors here, for instance, I can go ahead and put this thing that has a 3 as its power and that as a 3 as its power. So I could put them together. So I'm going to end up taking 2x cubed and add it to x cubed. Another piece that we have is, for instance, the next highest power. So I have a 5x squared. There are no other squared, so that's the only one. After squared comes a power of 1, so there's 2 things that have a power of 1. So we have a negative x, but then also a 7x. And then our last ones are our constants, or the numbers, and so we also have a 9 and a 4. So if we put all these together, 2x cubes plus 1x cubed means that we have 3 of them. The 5x cubed doesn't have anything that it combines with, so 5x cubed is its end. We also have a 1 or a negative 1x and a 7x, so we're going to end up with 6 x's. And then the last value is 9 plus 4, or 13. So in total, if we are going to add or subtract, in this case add, we're going to end up with the sum of 3x squared plus 3x cubed plus 5x squared plus 6x plus 13. And again, all it said was to add it and then write it in standard form. But if we wanted to name it, we could name it by the fact that it's a power of 3, meaning it's a cubic, and then it's got 4 terms, so it's a polynomial. So a cubic polynomial here. Alright, the next one is just a little bit different because it's actually the subtracting. So what I do every time that it's subtracting is I take the time to rewrite it, having distributed the negative. So every one of these pieces in this second term here is going to actually be the opposite sign of what it was originally. So this was a positive x squared, so now it's a negative x squared. This was a positive 6, so now it's a negative 6. And this was a negative x, and so now it's a positive x. So once you distribute, again, due to the subtraction, then we can go ahead and start combining like terms. So again, looking for the highest power, we have some squareds. So negative 2x squared and x squared are going to come together. We also have a power of 1, so it turns out there's only one of those. And then our numbers, or our constants, there's a 3 and a negative 6. So if we solve that, negative 2 minus 1x squared is going to leave us with a negative 3x squareds. Nothing happens to change the fact that there's just one x. And then the last one, the numbers, 3 minus 6 is negative 3. So putting all those pieces together in standard form, we're going to have negative 3x squared plus x minus 3. And practicing our names for that, the square means that it's going to be a quadratic, and then the fact that it has 3 terms separated by addition or subtraction means that this is a quadratic trinomial. Alright, so throughout this chapter you're going to learn skills for analyzing, describing, and graphing higher degree polynomials, which is what we're talking about. But until then, the graphing calculator is going to be a useful tool. So we do have a link on the website under our tools on HeadRush, and you can go ahead and get the graphing calculator there. I do recommend using that graphing calculator versus going through Desmos, because you're going to end up only really being able to use the graphing calculator on any sort of standardized test. So it does help you to actually practice using that one. So again, under the resources in your overview of this course, there's a TI-84 Plus Silver Edition that you can go ahead and get into. It will also be on the task board for today, so you can kind of have that to look at as well as something that you might end up needing. Alright, so taking a look at graphing our higher degree polynomial, they want you to graph it and describe the graph and identify the number of real zeros. So usually when I think of describing a graph, it's best if we actually take the graph and draw it. So what you're going to do on your TI-84 Silver Edition, if you click on the one that's provided for you, you're going to end up having to click through a few things. For instance, you're going to have to start by clicking actually start, because it's actually from the format of your online standardized test. So they give you this calculator all the time. So it goes to start. From there you press start again, and then you get to click on the little calculator icon in the top, and now you have a TI-84 Plus. So from that, we're going to actually graph this. So you go to your y equals. In your y equals button, you're going to end up typing in the equation. There will be this button that at the top says x, t, theta, n. That is where you're going to get your variable. Alright, if you end up actually using this like bunch of little letters that's in the corner of each of these buttons, you don't actually get the variable, you get something that might have been stored as that value. So either way, to get your x, we're going to do a 2, so you type 2, then x, then squared, and the squared key is on the left-hand side. Then you have to subtract and not press the negative, so there are two kind of negative values here, so the one on the most right column is your subtraction, but the one on the bottom row is actually negative, so you'd use that if we were talking about negatives. So then we subtract 3, and then right next to it an x. So once you graph that, you're going to end up with an image that kind of looks like this. And from that, we're going to describe the graph. So, I mean, we can just call it a parabola. That is the shape of a quadratic, so a parabola opening up. Alright, I mean you could also just call it a U shape, I suppose. They also want you to identify the number of real zeros. So remember that zeros are your x-intercepts. And if this is our x-axis, there are 1, 2 zeros. So we have 2 zeros, and our description is that it's a parabola opening up. Alright, then we get to type in our next equation, and the next one actually starts to get kind of interesting. So if you're going to do a fraction on the calculator, you actually need to put it in parentheses. So that's going to be your statement in parentheses. And of course you do want to make sure that you're using the negative sign instead of subtraction. So in our y equals, we clear out our previous and we end up typing in -1 division sign 6, and so you get this image. Then you'll type x and then do this little caret. The caret key is right above the division key. It looks like an N, but it's a tiny little caret. And so that's going to raise it to the power of 4. Then you actually have to click the arrow key. Oh, it doesn't actually look like that. It looks like a little triangle here to get out of the exponent. So if you don't get out of the exponent, you're going to end up kind of continuing to type up there. So after that, you'll press plus, then 2, then x, and then squared from that left column, and then subtracting 2. So if we do that and press graph, you're going to end up with an image that has kind of an M-looking shape. So let's see if I can draw this accurately. More or less. Okay. So the idea is that from there we're going to describe it, and so we can call it an M shape. That's fine. There will also be ones that flip upside down, so you could call those a W shape. And then from there we need to identify how many zeros. So how many times does it intercept the x-axis? And that's going to be 4. So 4 zeros. And notice that it is saying real, and that's because in the previous chapter, right, we talked about imaginary numbers, and that would be any time that it doesn't intersect the axis, but it still has a power that indicates it would. So, we're going to do quite a few examples that are just like this, so we're just going to graph each polynomial function and describe it. So, going back to y equals, we're going to type in that we're looking for 6x cubed, and anytime that you put cubed, you can either go to the math key, and then you'll see that there's an option on the math key for a power of 3, or of course you can just do the caret. The problem with the caret, of course, is that you have to press the over key afterwards, because otherwise you're going to end up continuing to type in that smaller text. So 6x cubed is entered, plus x squared, again that x key is up on the top, and then minus 5 x's, and then plus 1. So once you type that in, you press graph, and as long as you are using the computer calculator link, you don't have to necessarily change the window on this because it will go always to a standard 10 by 10. So either way, once you press graph, you're going to get kind of this snake-like image. Alright, and so I would call this N-shaped. Alright, and then after we call it an N shape, then we actually need to identify how many zeros there are. And there are 3 zeros that we can see, and so there are 3 real zeros. Taking a look at the next one, you'll see that it has a highest power of 2, and so it is going to be that parabola shape, or that U, or upside down U shape. So if we type it in, again going to the y equals, pressing clear, and then we type in 3x squared minus 2x plus 2, we end up with an image that looks like this. Alright, after that, again, they're trying to have you identify the real zeros, and there are no real zeros here. Because again, nothing intersects that x-axis, and so there are no real zeros, and to describe it we would call it U-shaped, or a parabola opening up. Alright, continuing on, and again the reason we're doing quite a few of these is just to make sure that we know how to use that calculator. So from here we go back to y equals, clear out our equation, otherwise they start to graph more than one at the same time, kind of hard to tell which one you're looking for. So we type x caret 4, and now we have to do our over key, otherwise you're not going to be out of that exponent. And then a subtraction sign and 3. Press graph, and we get a parabola looking shape. It does actually have kind of like a hiccup down here because of the degree of 4, but because it has only just a subtraction of 3, it's actually just a very wide looking parabola. Alright, from there we do see that there are 2 real zeros, but the problem with that is that there's a degree of 4, and so there should be 4 zeros, but of course 2 of them are imaginary, just as we are clear, and then we're going to also call it a U shape. Alright, and then our last one here has a power of 4, or what we're calling a quartic equation. So going back to y equals, if we graph this quartic trinomial, we have 4x caret 4, press the over key, subtraction of 16, x squared on the left-hand column, plus 5. If you press graph, ooh, that's quite an interesting image, we end up with a very kind of skinny, aggressive looking W, so it kind of looks like that. Either way, skinny, aggressive W ends up having 1, 2, 3, 4 zeros, which again is the maximum number since the power is 4. And so it has 4 real zeros, and then its shape is going to be a W. So hopefully we notice that anytime that we have an even number as its power, so notice a 4, a 2, a 4, and a 4, we end up with these U shapes or W shapes. Now as I'm looking at this, I do actually notice that I graphed this one incorrectly. Because I gave a parabola shape and it's clearly to the power of 3. So I must not have put that in correctly. So we shall redo that one, sorry. So again, going back to y equals, that's weird. I'm going to type in 2x and then caret and then a 3. Over arrow to the right so that I get out of the power, minus 3x. Go to graph, and we do actually have a odd shaped graph. So it's either going to be an N shape or kind of a backwards N. So we'll call it an N shape, and then we'll also identify that there are 1, 2, 3 real zeros. So, sorry about putting that in incorrectly. Apparently I decided a 3 was a 2. So, that's your polynomials. We've got naming the polynomials, we've got graphing with our graphing calculator, and then also adding and subtracting. So kind of a lot of pieces of intro to polynomials.